Okay, today we're going to look at how to graph logarithmic functions using Desmos. The first thing is the parent function, and when you're graphing a log, the basic parent function is going to be the log with whatever base in x, and that's all it's going to have to it. And then we're going to look at the transformations and key features that we've looked at before for other functions. So we're going to start off by going into our Desmos graphing calculator. And I'm going to type in as f of x, not y, so that we can look at the table values. So remember, you just click below, or you can click the plus and add an expression. You just type in the word log, and if you do the shift underscore, it'll make it a subscript. You have to do your right arrow, so it's off of the subscript to put your x value. So that's what the log of base 2 of x looks like. For the most part, all logs will look like in this shape. The only thing difference is it might be transformed. But the parent functions all look like this. And then they all have that y-intercept or x-intercept of 1, 0. And then you look at your transformations from there. Now, that's a base 2, so it goes through the point of 2, 1. If it was a base of 3, it would go through 3, 1. If it had a base of 5, it would go through 5, 1. Okay, so that kind of gets it closer and closer to the x-axis as the base increases. I'm going to hit the gear in the table of values just to kind of look at some table of points. Notice that -2, -1, and 0 is undefined. That's because this log graph has a vertical asymptote. That means a vertical line that the graph does not cross. And we can add in some more points. I just picked in nice ones, but we could have included 3. So that means it's going to have some decimal values there. Okay, so that's your basic log graph. Okay, so if we do our snipping tool, we can snip that and insert it into our documents. I have already taken care of that. So there's our log graph. All right, so one of the things that we talked about for there when we were just talking is we talked about this has what's called the vertical asymptote. And the vertical line is going to be in the form of x equals, so it's x equals 0. So that's for your parent function. It'll always start out to have that vertical asymptote of x equals 0 and go through the point of your base and then a 1. And then we're going to look at transformations of that. The domain, because it doesn't cross that x-axis, goes from 0 to positive infinity. Remember, domain are your x values going left to right. Range goes from negative infinity to positive infinity. So it goes from the way bottom and it keeps on increasing. It gradually increases. It increases slowly. Okay, so then when I want to know what's the inverse of the log, when we look at that, and we want to know what the parent function of that is, I want to remind you guys of how to find an inverse. So we know inverses of logs are exponentials. If you are wanting to graph the inverse of a log and you need to actually find the inverse, what you'll do is you remember, this is a little bit of review, to find an inverse, you switch your x and y, and then once you switch x and y, because it's a log function, you're going to write it in exponential form and then solve for y. So for this problem right here, if I switch my x and my y, okay, so if we switch our x and our y, we're going to have x equals log base 2 of y. And I'm just going to rewrite it. So the log is to the left-hand side. And then to write it in exponential form, that's where we make our loop. So we start with our 2, we raise it to the x, and it's going to equal y. So the inverse of this log is 2 raised to the x. So we go and graph 2 raised to the x, and I'm going to put that in as a function g, so we can make a comparison of tables. 2 raised to, so you make shift 6 and make the exponent. the x. I'm going to hit my gear, and I'm going to change that to a purple graph, and then we're going to hit our table of x. So basically what's happening is it's crossing over that line of y equals x. It's a reflection over that line. If you look at your table of values, if you notice the log function went through 1, 0, and the exponential goes through 0, 1. The log goes through 2, 1, the exponential goes through 1, 2. The log is 2, 4, 2, and this one is 2, 4. And that's what inversely should do. Your x and your y values should be switched. That's good. So that's your exponential. So again, you can snip it to insert it. Now the exponential function, I found that this was exponential, has a horizontal asymptote. And the horizontal asymptote is y equals 0 because it's not crossing that x-axis. So the y values aren't becoming negative unless you do some kind of shifting or reflecting. Okay, so the domain of the parent function comes from negative infinity and continues to positive infinity. And the range goes from 0 to infinity. Now we looked at the table to see that the x and y values are switched. Remember, domain are your x's, the range are your y's. And notice from our parent function, the domain and range, when you have the inverse, those domain and range are switched. So the domain becomes the range, and the range of the log becomes the domain of the exponential. Okay, so these are some review of transformations. Every transformation we've learned to this point is the same concept. If you add or subtract a number to the actual x value, that moves your graph left and right. So if that was x plus 3, it would move to the left 3, and if it was x minus 3, it would move to the right 3. For this function here, the whole parent function is log base 2 of x. That can be of any base. We're adding b at the very end to the y's. You're adding b, so that moves your graph up and down. So if b is positive, it moves up. If it's negative, it moves down. And then if you change the number in front of your log, that gives you a vertical change. So it's actually changing the y values. So you vertically stretch it if that number is like a 2 or a 3 or a 5. And then if there's a number between 0 and 1, it's going to vertically shrink, like a half, a fourth, 2/3. If the c value is negative, it's going to reflect over the x-axis, and remember, if that x is negative, then it's going to reflect over the y-axis. So that's just a review of a few transformations. Okay, so the first thing we're going to do for this problem is we're going to state the parent function and the transformations, and then we're going to graph both the parent function and the transform function. So we're just looking at how to graph these transformations. Okay, so the parent function is your most basic function before you do any transformations. So in this case, the parent function would be y equals log of x. There's no base, so it's understood to have a base of 10. Okay, when you look at changing the x, that shifts your graph left and right. So this graph is going to shift the parent function to the left 3. And the minus 5 at the end is going to be going down 5. Okay, so I'm going to type in f of x equals, and I'm going to start with the parent function of log of x. Okay, and then we're going to get our transform function. And that's log of x plus 3. There's your parentheses minus 5. So I am changing my zoom so it is going up by ones. So if you, as long as you see that 5, the negative 5, positive 5, negative 5 on your axes, that's moving all ones. Now, if you look at the parent function, it does not actually stop here. Remember, it's getting closer and closer. It kind of blends together, so it's hard to see. But if we take, remember the base is 10 here, so we know this goes through that point of 10, 1. So if we take that point of 10, 1, and we do the transformations we talked about, which was going to the left, 1, 2, 3, and then down 5, 1, 2, 3, 4, 5, we have our new point right here. So basically what's happening is when you're shifting left and right, it's actually going to shift that vertical asymptote also. So now it's not approaching 0 for the transform function because it's shifted over to the left 3. Now at negative 3, that's where the graph is approaching. So we snip it to the picture and insert the graph. Now my graph here, I have points already. That's because when I was in my Desmos graphing calculator, I actually hit the gear and then the table, and it gives you points. And if you want to populate more points, like on the parent function here, if I put 3, 4, 5, it adds more points. We're talking about that point of 10, 1. Okay, the other thing that I do want to mention here that we talked about is the new graph now has what's called a vertical asymptote. X equals negative 3. So it does not cross that negative 3. And oops, if we were going to look at our table of values, we don't have any errors here, but the last negative was negative 2 for the transform function. So if we add in like negative 3 or negative 4, and then negative 3.5, you're going to have undefined because it doesn't pass that negative 3. Okay, next example. Okay, so we're again doing the same information, given the same information for our parent function. We have y equals log, this time it's base 3 of x. For our transformations, that 20 gives you a vertical stretch. Because we negated the x, it's going to reflect over the y-axis. And then the plus 3 shifts our graph up 3. Okay, so I'm going to put in my parent function first, which is log base 3 of x. And then our transform function. Okay, Okay, so it kind of loses its shape because of the stretch. So the stretch is like really, because of that stretch, it's kind of stretched it way high. I'm just going to kind of zoom in. So you can see it still has the bend to it. So our parent function is right here, and then this is our transform function right here. So basically what has happened is you're taking, so the base was 3, so you're taking that point of 3, 1, and then you're tripling the distance from there. So it becomes 3, instead of 3, 1, it becomes 320, and then you're reflecting over the y-axis, and then you're going up 3. So it's a big stretch. Okay, so when you looked at the vertical asymptote, because it didn't shift left or right, the vertical asymptote was just on the other side. It's x equals 0. It was just on the other side of the x-axis. And then we included our function and the parent function. Okay, one last graph for number 5. The parent function for this one is, because you have a base of 5, would be y equals log base 5 of x. So when we look at our transformations, this negative on the outside reflects over the x-axis. The 1/5 gives you a vertical shrink. And then the -4 would be x. When you change your x, that's left and right, and it's the opposite. So x minus 4 means you're shifting to the right 4. So our parent function was f of x equals log base 5 of x. Oops, x. And if you hit this little home button, it'll take you back to the original zoom. So that's going through the point 5, 1. So it's going by 5s. So it's going to start through the point 5, 1 because your base was 5. Well, looking at the table. There you go, 5, 1. And then to get our transform function, it was negative 1/5. Arrow to the right, so you're out of the denominator, and then log base 5. So remember, shift underscore is the quickest and easiest way to get your base. And it was of x minus 1. So we're starting off with the log base 5, and basically if I take that 0.51, we said the transformations were that it was reflecting over the x-axis. So if we reflect over the x-axis, we'd be here. Then you're taking 1/5 of that distance, so that would be 5 1/5. And then from 5 1/5, you're shifting to the right 4. So it would end up right there. Would be your point. So I think if we put in a 9 to that value, that'd be negative 1/5. So that's what we were talking about. Okay, so all these are undefined because it doesn't go past. Remember, when we shift to the right 4, that changes your vertical asymptote. So if we get into after 2, let's go to 3, 4, 5, so 5, 0. So we're looking at 5, 0 as being a point, so it's between 5 and 4 that it keeps getting closer and closer. So it's actually 4, because remember that vertical asymptote also shifts left and right as you shift. And this one does not stop, it just keeps getting closer and closer. It's just not showing it. Okay. And then the vertical asymptote, we said we're going to state our vertical asymptote. So for the transform function, the vertical asymptote was x equals 4. All right, so for number 6, we're going to graph the function, but we're also going to find the inverse and graph it. And then we're also going to graph the line y equals x to look at that, what it does. So remember, to find the inverse, you switch x and y. So f of x is like your y, so it's going to become x equals log, the x becomes a y. And what we're trying to do is we're trying to solve it for y. So I'm going to first add 5 to each side. And I'm going to rewrite my log so it's to the left-hand side. Okay, once you get the log by itself, that's where you write it in exponential form. So remember, the log is base 10, but you have to have the log term by itself. So when we write that, we're going to take that 10, we're going to raise it to the x plus 5, and it's going to equal y plus 3. So we have to subtract 3 to get the y by itself. So that's the inverse. And we're going to look at our table of values to make sure that we did find the inverse correctly. Okay, so our log function was f of x equals, that was a base 10, so we don't have to put a base. That's log of x plus 3, and then minus 5. And make a table of values. And then we said the inverse, I'm going to call that g of x, so we can get a table of values for that. Function g of x is 10 raised to the, now when you do raise it to the power, and it's not just x, you have to put the power in parentheses. So that was x plus 5. And then at the end, plus 3. I'm sorry, minus 3. We would have found out real quick it wasn't the inverse. And I'm going to hit my gear in my table. And I'm also going to go ahead and get that y equals x in there. But it has to graph. So y equals x is actually your, y equals x is a line, and that's what the log function is transforming over, is that line. Now, if we have up here we had -5, -2, -5 for the log. So if I switch that and make my x be -5, notice it switches the x and y's right there. Or same thing up here, if I put in 997, it's -2 for the x. So I do know that I found the correct inverse there. And so again, you can zoom it so it's going by ones. We did not have a whole lot of points that we saw here because between -2, they're actually very, very small for the function. I meant the inverse right here, because these are so big. So we would actually probably have to make some smaller values like -4. If you're looking to get more points on the graph. -4/7's right there. So you can add some more. -3 won't be too big. 6. There we go. So we got -2.9 there. And so when we there we go. Okay, and then on the final example, it's asking us to graph negative log base 3 of x plus 1 minus 2. So you go into your Desmos and you type that in. For time's sake, I've already done that, so I'm just going to pull up the graph. And then what it wants to know is it wants to know the transformations and it wants to know the parent function. So we'll just start with the parent function would be y equals log base 3 of x. And then what's happened is that negative reflects the graph over the x-axis. Shifts your graph to the left one. And the minus 2 makes your graph go down 2. So originally, because it's a base of 3, we were at 3, 1. So we took that point of 3, 1 and we reflected over the x-axis. And then the graph went to the left 1 and then down 2. Okay, so now to state our key features, remember domain is your x values. So because it shifted to the left 1, when it's shifting to the left 1, it doesn't cross that negative 1. So the domain would be from negative 1 to infinity. Domain goes from left to right. The range, it keeps dropping lower and lower. So that is from negative infinity all the way up to positive infinity. That's your y's that run bottom to top. Positives above the x-axis. So that goes from negative infinity to that point right here of negative 1. And then negative is below the x-axis, so from 1 to infinity. Negative 1 to infinity is below, or yes, below the x-axis. Increasing is going uphill. No part of this graph is going uphill, so that's not available. Decreasing is downhill. The entire function goes downhill, so that's from negative infinity to positive infinity. Our x-intercept is at that, remember on the x-axis, that is an ordered pair, that is the point negative 1, 0. And the y-intercept is at the point 0, negative 2. And then finally for the end behavior, remember it's where your ends are. So we'll say as x approaches negative infinity, so there's two ends. It's in the second and in the fourth quadrant. So as x is approaching negative infinity, the y, which is our f of x, is approaching positive infinity. And then as x approaches positive infinity, the f of x, the y values are going down, so that's approaching negative infinity. So that's your basics of graphing log functions.